the stepper drivers have now been fitted with the heat sinks, and to fit the heat sinks, just get yourself a pair of bent tweezers, again buck each, and they're quite easy. You just hang on to the heat sink like that, fingers, peel it off, and then you can line it and push it on. So it's very easy to use the tweezers to put it on and align it. So again, order these before you order the kit and you won't have any problems. Any items that I do show you throughout this whole series, at the end of each video there'll be a QR code similar to the one you've seen at the start. Pause the video, especially at the end. You only have about 10 seconds after the logo. Pause the video, get your smart camera out, take a photo, and then it will list all the parts, dimensions, suppliers, whatever I happen to mention, video links, etc. will be on that. So make sure you do that for every video, because each video will have a different one. So once you've fitted your blocks to your electronics, it's then just a matter of wiring it up. Now you can use the plugs that came with the stepper drivers, and they're just X, Y, Z, and the extruder 1 is on the left hand side, extruder 2, so you only have to put 4 stepper drivers in it, and the 5th one is for that, or spare in case you stuff it up. I marked mine X, Y and Z, and on it you'll see there's 2 ridges, and it's red, blue, green and black. So the red is on the left hand side, so those ridges face you, and then you just slide it in. Then you've got your limit switches, it's X, Y and Z. Now because this board is designed for an upper and lower limit, there are 2X, 2Y, 2Z. On the left hand side of the board, miss a row, X, miss a row, put the Y, miss a row, put the Z. Fit the LCD. Now I've mentioned the LCD before, and if you've got a laser cutter you can work out the design of where the buttons and all that go. There wasn't any dimensions that I could find for this particular style, so I just measured it all up and done a DXF, and go out to your laser cutter, cut it, put it on, yeah, about 1/2 mil that way, done it. So 3 or 4 cuts, old wet bix container, cereal container, and it's done. Then that twist and push. Well, luckily it's continuous rotation, so you need to either make a knob or buy a knob. This particular knob has got the flat, it's a 6mm shaft, and it's a 4.5mm across there, so you take off 1.5mm, and it's 5mm deep. So I had these types of knobs. They don't have a flat in there. They're for the pots with the spline push in. So I just made up this little tool. Just a shaft. I turned it down because I didn't have a bit of 6mm I wanted to waste on that. So I just turned it up 6mm, milled a flat on it, and that is 1.5 off, 4.5 thick. Then all I did, I put it in a drill chuck. You can use, it's on the mill, but you can use a drill chuck, whatever, drill stand. And I just heated it till it got warm with the paint heat gun. It doesn't have to be red hot, just warm enough to make the plastic soft, not to melt the plastic, just to make it soft. And then I just, when it was warm, a couple of 30 seconds, 20 seconds with the heat gun, could feel it. Then I just pushed it in, and then that formed that shape into the spline. Then I just pushed it on, and it was on there securely. Then when I do the design for the cutouts, instead of the flat, I'll have to make it that diameter to clear the knob. There's a little emergency stop button there, that's a speaker, and that's an adjusted trim pot, which you don't really need access to. But the other problem with the LCD, can you see the angle up here? The green should be parallel to the red. I'll just grip this here. There's a couple of stops in there, and it needs to be squashed down. It's where they soldered it on. I didn't have it clamped down properly. Can you see the gap in there where the stop's supposed to be? Also, the holes. They're supposed to match. They don't. The board is up and across. So when you try fitting a screw in, you might be a bit cockeyed, let's say, might be up there, down there. But then even when you try to then clamp the boards together, it's going to pull the screw. So when you make your template for your holes, you measure it up, it's fine, but then you have to adjust it to be practical. I will make up another template, cut out the holes, then squeeze it together and see if it lines up. So that way you can tell that the holes are lined, and when you 3D print a cover, let's say, you know exactly where to put the holes. I've marked with Technicolor 1 and 2, but if you look under here, it'll tell you the numbers. I like to be able to see things easy, so that's 1 and 2. They're also marked on that board, but again, you write 1 or 2 that in, you write 1 or 2 the other end, so then it's just a matter of fitting that like that. Now the reason why I'm going to mark it is that when the board is fitted, I've ordered a drawer slide, you know the ones you have on in your kitchen for your drawers, the little ball bearings. Smallest one I could find was 200mm, so I'll just mount one of those onto the side of the power supply. It will come in and out. I'll make up an L bracket that will fit to the side of the slide itself and come across, so that will be on there, and it will just screw on there, and then I'll be able to slide it in and out. I could try and mount it on the front and at the back and all that, so I just thought I'd try that, see how it goes. And that's why when you've mounted up your cable and it's going around here and back there, over there, it's twisted. Is this 1 or is this 2? You don't know. So if you just mark them, you won't have problems later. So that's basically the electronics. The jumpers were already put in when the board came. You might see some other manuals will show you that they're loose, but you just put them in underneath where the steppers drivers would go. So that's basically the electronics assembled. Then it's just a matter of the wiring.